Today we're going to look at expanding and factorising expressions. In the learning goals for today's lesson, we're going to be able to expand expressions using and including binomials, and also factorise expressions including differences of perfect squares. So remember the distributive law, we use that to expand the brackets, and we need to simplify results wherever possible. So for these examples here, the A needs to be distributed to the B and the C to get AB times AC. Same with A times B, A times the minus C, we get A, B minus AC. If we ever get confused with the negatives inside or outside everything, remember we can just write this as A, B plus negative C, and then we can remember that multiplying a negative times a positive is a negative, and it all sorts itself out in the end. Remember with binomial products, we need to multiply the A here by the C and the D to get AC plus AD, and also the B times the C and times the D to get BC plus BD. Some special cases of this is if we're expanding squares. So if I've got A plus B all squared, then that actually comes out being the first thing squared plus 2 times the first thing times the second thing plus the second thing squared. And if it's A minus B all squared, it turns out to be the first thing squared minus 2 times the first thing times the second thing squared plus the second thing squared. We can also form a difference of two squares, or a difference of squares, or a difference of perfect squares. If we see A plus B times A minus B, anything in this form, and that yields A squared, the first thing squared, minus the second thing squared. That's the difference of two squares there, the difference of perfect squares. Looking at some examples now. First example that we have here is x, 2x minus 1 minus x, 3 minus x. So looking at expanding the first part here, I get x times the 2x, which is 2x squared, then x times the minus 1, which is minus x. Then I get minus x times 3 minus 3x, and minus x times minus x, which is going to be plus x. So I get 2x squared. If I'm going to simplify this, 2x squared is going to not be simplified. It's not like terms with anything else, but I've got all of these x's here, and the minus x plus x cancel, so I'm just left with the minus 3x. For b, I've got x minus 4 squared, and it's of that form a minus b squared. So we know that it's going to be the first thing squared, x squared, minus 2 times the first thing times the second thing, plus the second thing squared, 4 squared. So we can simplify this, x squared minus 8x plus 16, and that's our answer for B. For C, we've got 2x plus 1, 2x minus 1. This is of the form a plus b times a minus b, so this is going to form the difference of perfect squares. So what we have is our first thing squared, 2x all squared, minus our second thing squared, which is just 1. So we can simplify this. Now remember, index laws, that squared needs to be distributed to everything inside. So it needs to be 2 squared, which is 4, times x squared, minus 1 squared, which is just 1, and that's our answer. For D, we've got 2 times x minus 3 times x minus 2. Now there are a couple of ways we can do this. We can initially start by expanding the 2 into the first set of brackets, or we can leave the 2 out the front, expand out the binomial expansion, and then multiply that at the end. That's what I'm going to do for this one, but you can do it the other way if you feel so inclined. So, doing my expansion, I might not put that there. Let's do this expansion. X times x is going to be the x squared. I've got the x times the minus 2, minus 2x. Minus 3 times x is minus 3x. And minus 3 times minus 2 is plus 6. So I can simplify inside the brackets now and get minus 5x plus 6. And now I can distribute that 2 to everything inside the brackets. So I get 2x squared minus 10x plus 12 by distributing that 2 to everything inside the brackets, multiplying everything inside the brackets by 2. Looking at E now, I've got x plus 2, x plus 4, subtract away x minus 2, x minus 5. I can expand these out to see what I get. We need, the tricky thing to remember with this sort of a question is I'm subtracting away here all of the second binomial expansion. So I'm going to keep that in brackets to remind me of that. So the first binomial expansion, x times x is x squared, x times the 4 is plus 4x, 2 times the x is plus 2x, and 2 times the 4 is plus 8. Now, as I said, I'm going to keep this whole last thing in brackets to ensure that I remember that I'm subtracting away the whole of that expression, that binomial expansion there. So I've got the x times the x, and that's the x squared. X times the x, and that's the x squared. And then I've got x times minus 5 minus 5x, minus 2 times x minus 2x, and minus 2 minus times negative 5 is plus 10 there. So simplifying in this next section, 2x's plus 4x's 6x plus 8 minus x squared minus 7x plus 10. Now if I'm subtracting away this second expression, that means I'm subtracting away everything inside those brackets. I'm subtracting away the x squared, I'm subtracting away the negative 7x, I'm subtracting away the 10. So that means this is going to be the same as 6x plus 8 minus x squared plus 7x, because I'm subtracting negative x, and taking away 10. I can now simplify. I've got x squared minus x squared. Those cancel. I've got the x squared and I take it away. I've got 6x and I add 7x. That's 13x. I have 8 and I subtract away 10 minus 2. So that is our expanding that slightly more challenging question. Remember, if I'm taking away that binomial expansion, I'm taking away the whole thing. Let's look at factorising expressions now. So remember, you can factorise expressions with common factors by moving the common factor outside the brackets in the reverse process of expansion. So we look for the highest common factor. For this question that we have here, this 4x squared minus 8x, the highest common number is 4. And the highest common variable we have is x. So our highest common factor, 4x. We've taken it outside the brackets there. Now I divide each of the terms in the expression by that highest common factor and have those in the brackets. So 4x squared divided by 4x is just x, and minus 8x divided by 4x is just minus 2. So that's what I'm left with inside the brackets. I am also looking at, I can factorise a difference of perfect squares. So our difference of perfect squares, I would see any two numbers subtracted away from each other. I can factorise that even if one of them isn't a square, because I know that for the example that we have below, 5 is equal to square root of 5 squared. So that means that any number I can take and I can factorise if it's the difference between that number and another number, or that number and another variable. So it means that for the example I have here, it's always going to be the first thing, or the square root of the first thing, minus the square root of the second, plus the square root of the second thing, times the square root of the first thing minus the square root of the second thing. So for our example here, I've got x squared minus 5. So x squared, the square root of x squared is equal to x. The square root of 5 squared, the square root of 5 is square root of 5. Okay, so we've got here the first thing plus, the square root of the first thing plus the square root of the second thing times the square root of the first thing minus the square root of the second thing, and that's our factorised form of a difference of perfect squares. You can check about expanding this back out in the opposite direction and seeing that you'll be able to get a squared minus b squared. We can also look at factorising 4-term expressions if possible by searching for and factorising each pair for the 4 terms, so the first 2 terms and the second 2 terms. Now this is an important skill for when we look at factorising more complex quadratic equations, so it's important to practice this skill especially. So if I've got x squared plus 5x minus 2x minus 10, I can see that there is a common factor for the first 2 terms of x. So if I just look at the first 2 terms and then I look at the second 2 terms here. So if I look at the first 2 terms, the highest common factor is x. The highest common factor for the second 2 terms is 2. But if I see the actual goal is for me to find something that is going to be common after I have factorised both pairs. So after I factorise the first pair, I get x being the highest common factor, and then I get x plus 5 in brackets. Now if I look at the second pair, I can get x plus 5 in brackets too. I can get x plus 5 in brackets as well, but what I need to do is not take out 2, I need to take out negative 2. If I take out negative 2, then as the factor that I take out from the second pair, then I'm left with x plus 5 inside the brackets. Then what this leaves me with is it leaves me with a common factor between the first 2 and the second 2. And the common factor is the x plus 5. So we can see on the right hand side here of the equation, I have factorised the first 2 terms. I've got x times x plus 5. And I factorised the second 2 terms by taking the minus 2 outside of the brackets and it being the highest common factor, leaving x plus 5 in the brackets. So now, if I perform this factorisation again from the first term in the new expression to the second term in the new expression, then it means that I take the common factor of x plus 5 outside of the brackets and I'm left with x minus 2 being the leftover bits, the x minus 2. So that's what can go outside of the bracket. So then if I expand that out again, you can see that I'll be able to end up with what I started with. Let's look at some examples now. Let's look at firstly at a. I've got 20a squared plus 30a. So the highest common factor here is going to be 10a. Take it outside the brackets and I'm going to be left with 2a plus 3 inside the brackets. And that's it for that question. Next one, 2x plus 1 minus a x plus 1. The common factor between the 2 terms is x plus 1. So I'll take that common factor, x plus 1, outside the brackets, and then I'm left with the 2 and the minus a. So I'm left with 2 minus a as the leftover parts after taking my highest common factor out. Looking at C now, I've got 12y squared minus 1200. Now this one's a little bit deceptive. It looks like a difference of perfect squares, but 12 itself isn't a perfect square. 1200 isn't a perfect square either. However, when I'm faced with a question, I can try and factorise by simplifying. So if I can simplify this further and find a common factor here, maybe it will help me factorise it even further. So a common factor between both of these terms is 12. So if I take 12 outside the brackets, I'm left with y squared minus 100. Now, I could stop there, but I haven't really fully factorised this because I haven't found all of the factors of the initial statement. I can still factorise this because what I've got here is a difference of perfect squares, y squared and 100. So I can actually say, well, I know that if I've got a plus b times a minus b, then that gets a squared minus b squared. So I've got the a squared minus the b squared. And in this case, a is y and b is 10, because 10 squared is 100. So here I got 12 multiplied by, I'm just going to do this step. This is the y squared minus 10 squared. Don't need to do that step, but it can be helpful to see what is a and what is b, because now I can say, well, this is the same as y plus 10 times y minus 10. And now it is fully factorised. Now, our answer to C is now fully factorised. Looking at D, I've got here x plus 3 squared minus 4, another difference of perfect squares. The first one's a square, the second one's a square, because this is x plus 3 squared, and this is 2 squared. So I've got my A and my B. So A is x plus 3, B is 2. So if I do x plus 3 plus 2 times x plus 3 minus 2, and I can simplify this to be x plus 5, x plus 1, I've fully factorised that expression. Looking at E, x squared minus 24. 24 isn't a perfect square, so this one's going to be a little bit more challenging, but I know that this is equal to x squared minus the square root of 24 squared. So I've got my A and my B now. So this is going to be equal to x plus square root of 24, x minus the square root of 24. Now, it's not as simplified as I could possibly make it, because I can simplify those surds. So the surd of 24 is underneath that square root sign. I can make that 4 times 6. So I can go x plus square root of 4, square root of 6, x minus square root of 4, square root of 6, which is equal to x plus 2 root 6, x minus 2 root 6 for that question F. Here I've got another one that looks like it might be presenting as a difference of perfect squares, but it doesn't look super obvious. Once again, I can show where those squares are to make sure it's nice and clear. So it's square root of 5 squared is our second square there. So I've got my A being the first one here, and B is the second one here. So we've got A squared, which is x minus 1, plus B, plus root 5. And then our x minus 1 minus root 5. Now that's as simple as we can make it, because we don't have any like terms. In order for us to simplify the minus 1 and the root 5, they'd have to be like surds, and they're not like surds. We don't have any like terms with x either. So we're fine to leave it at that stage, at the x minus 1 plus root 5 and the x minus 1 minus root 5. They're as simple as they're going to get. G. This one we're going to factorise by grouping. So we've got x squared minus x plus ax minus a. Let's look at grouping the first set of terms first. Look at the highest common factor. The highest common factor that we have is x, so we can take it outside the brackets. What I'll be left with inside the brackets is x minus 1. Now, I want to try and get that x minus 1 being over here. I want something here that I can have, and then have x minus 1 in the brackets. So if I look at the two values above, I've got ax minus a. If I take a common factor of plus a out, then that'll leave the x minus 1 in the brackets. So if I go that plus a, that will be easy then to factorise for the second step, because now we've got the common factor of x minus 1. Take that common factor of x minus 1 outside the brackets, and we're left with x plus a. Just to recap on our learning goals for today, we've learned how to expand binomial expansions, expand expressions including binomial expansions. We've also looked at being able to factorise expressions including differences of perfect squares. We've also been able to look at grouping, factorising using grouping and other methods like that.